Hello, I am Aman from Team Scada 3301 and we are excited to present our solution Scada Verse for boat hackathon. Today, a crane operator in a major Indian port can lose 40 million rupees in a single day due to an axle failure that could have been detected weeks earlier. Similarly, an airline recently in India has faced 200 million rupees in losses from an unscheduled engine shutdown. The reality is, machines rarely fail without warning. They whisper tiny signals, vibrations, heat anomalies, or just even little gestures from their data that tell us that there can be subtle misalignments weeks before the catastrophe even strikes. The problem is that we don't listen to these signals. So Scadaverse changes that. We envision a world where every industrial machine has a living, breathing digital twin watching over it every second, predicting failures before they even happen, and encompassing all that into a data dashboard. Just like a smartwatch shows your heart rate, a system shows your machine's health live in 3D intuitively. We believe accidents, unplanned downtime, and unnecessary maintenance should become stories of the past, not everyday headlines. So here's what SCADAverse brings to the table. Well, with real-time 3D digital visualization, twin visualization, a live interactive 3D replica of your equipment with real-time overlays of vibration, thermal, and acoustic data, making it easy for even non-technical operators to understand and the machine's health visually, where they have to just open the dashboard and see how the machine is performing based on the indicators provided by the SCADA system. Next is the predictive analytics engine, where the AI ML comes into the play. Our AI predicts the failures weeks to months in advance, allowing maintenance teams to act before disaster even strikes. This helps in predictive maintenance over the past data of the particular machine, or even in suggesting whether there can be a load failure in future. And there are some optimizations that can be made in future in the system. Next is simulation and testing, where operators can safely simulate overloads, emergency scenarios, or even environmental changes on the digital twin before applying them to the real system. So that is a very major use case for a crane like disaster where you can stress test the machine beforehand in a digital twin and operate on it while testing it in the digital twin platform. So we process the data locally in for instant alerts while leveraging the cloud for advanced predictive analysis, where we store the data for remote web dashboards and processing it for instant alerts locally itself. So there is seamless multi-sensor integration that comes with it, where vibrational sensors, thermal sensors, acoustic monitors, and your existing PLC or SCADA data are combined effortlessly with our system to show how there can be a maintenance or how there can be how well is the system performing at the moment. For that, we have developed a SDK and library support with our system, where the user has complete control over the development phase of their own project, where they can plug and play with the SDK, enter their project token, map the sensors with the sensors that they have set up in the digital twin by editing the 3D model that we will see in a second in the project prototype. And coming to why does it even matter? Why is Scadaverse? Why is it even useful? Well, because downtimes costs industries over 0.5 to 2 million rupees per hour. Safety incidents can risk lives and cause financial losses. Current systems are reactive, slow, and unintuitive. So, Scadaverse transforms monitoring from reactive to predictive, intuitive, and actionable, where we provide with SDK and library support and end-to-end connection solely on the developer or the owner of the project. We, of course, they can hire our team to set up the SCADA systems for them. But again, there has to be all the control available to the user that has already purchased the digital twin and has complete control over whether they want to, how they want to make the digital twin, how they want to add the sensors, which sensors they want to add, and which data they want to fetch, they want the mapping of the sensors to be. So all that in just a single platform. Now let's take you through how SCADAverse works in action. Okay, hi. So coming to the prototype, we'll start with the Twin Builder application that we have built for the interactive twin editor. So I have two twins right here. The user comes, they log in, they set up the credentials, and they're accessible to the platform right from the front. I can create a twin right here. I can show you the existing twins. This is the data for pump one. Of course, we do not have not set up actual sensors at some area, but we have tested the protocol with ESP32 sensors, ESP32 controllers, and gas sensors. So data is validated very quickly. I'll show you the demo at the end after this, where there is actual data. And right now on the screen, there is what the user will be saying for their particular digital twin is what is the system health, the efficiency, the uptime, the power usage, of course, the 3D view of their system and how the sensors are performing, the analytics and the controls, how they can control their particular um, the digital twin. So the digital twin will look somewhat like this in real time. It will have real-time data. It will be coming from backend. You can actually set the button state to control the system, set it manually or auto or stop it. And you can see the lifting operations, the motor operations. So this one is particularly for a crane system where the data is actually coming from the MQTT protocol, but it is randomized for now so that we can see the alerts going up and down, and the alerts are here on the right hand side. I'll just close them. There are 41 alerts right now. So on 3D view, I can see the 3D view of the crane, and if there is any stress test, the color of this particular mesh will change from green to orange or something else from the alerts. So here it is, the red color. Here's the load, here's the motor status, the OS, the temperature, the humidity on the particular sensors that are set up here. So these are supposed to be the sensors that are set up at a particular site, and the data is coming here from that particular area. So it is connected with the WebSocket at our backend server here. This is the backend server running. We have connected this client and we are receiving the data from real time. And there are alerts. Okay, so I'll just quickly walk you through how you can set up your own twin builder on the website. So you can set up one for crane. I have already one set up here. So this is for crane. I can control the crane. I can operate on it. I can hose down, skew it left, even put an emergency stop to it. I can adjust the wind speed limit on which I want to send an alert to myself. I can adjust the load limit, the speed limit, and any particular data that I want to control from the dashboard. So much to see, so much to learn, and so much to implement in the real case for digital twins and the system architectures, the systems, sorry, my bad, the systems that are actually being implemented right now in the industry. And this can actually help us get the data that we need to predict any catastrophe from beforehand, as I stated before. So I'll just quickly create a twin here. Let's create a twin for smart buildings, yes. And it's a building, let's say, four story building. A It's a building. Its location is Mumbai, India. 10 floors. Yeah, yeah. And we have 5 seconds of data interval. These are the configurations that you can set while creating your own twin. I'll use the default model for now. And this is the reviewing page that we have to, these are the 4 steps before you create a twin. And after the twin is created, you have all this data here. Of course, it is not real-time data because again, setting up a building with sensors is not feasible. But yes, it is going to look like this in real time. There will be sensors associated. You can see the data and boom. So the 3D view is ready here. I can edit it. I can add sensors here. I can add models here, sensors here. I can just add them, drag and drop them, see their data in real time. Right now, the data is coming from no backend, so it is empty. Since it is just set up, I will in real time set up the data, set up the sensors, integrate them with the SDK. I'll take you to the SDK now. So these are the analytics before moving forward. You can toggle them as per your need, the temperature, the vibrations, multiple options available, and the controls are also easy to operate. If suppose I want to set the elevator service to stop, since there can be a problem. I see temperature readings going high, so let's cut the power down for a while. There can be a problem. The HVAC system, there's a complaint from somewhere, so as a remote operator, I can edit it. I'm a, se- I'm a security guy of the particular building. I'm the secretary. I have a complaint. I want to shut off the security system for a while. There is a issue from someone, yada yada yada, and yeah. So this is for the analytics part and for the twin builder part. Yes. Coming to the AI modules part, so we have actually three AI models. One for a simulation sandbox. So suppose I want to simulate how the data will actually be responding and coming, and I want to see that what will happen in that particular scenario. So beforehand for building the project, I can see that what will be the outcomes. We have LSTM encoder, and for LSTM engine, we can use LSTM, my bad. LSTM engine is for the real-time checking of data, the simulating the data. We have graphs here, how the simulation steps work. So this particular data is for uh, this particular data is for an engine to work, how the engine will be working. So these are the graphs for that data. It is all stated in the GitHub repo, so you can get it from there. It's in this folder. And coming to the encoder part, it is for predicting the anomalies and to see if there can be an anomaly in the future from the past data. So these are the matrices here, these are the graphs and the prediction and the precision of data, how the throttle can affect the machine's efficiency overall. Here's the spike here. And moving to the SDK now that we have developed for the microprocessors and microcontrollers. This is the SDK. So for microcontrollers and microprocessors, they can use the SDK, particularly for Arduino or let's say ESP32. They can import the SDK and they can use it in their microcontroller to set up with our Scada Verse and just get it going with their flow. So you can set up, initialize it, register the sender, send data, send the command handler. Let's say if I want to change the direction of the crane, the command handler will say hoist it left, hoist it down, hoist it right. So what sets Scada Verse apart is actually the rapid deployment and onboarding in weeks, not months. The scalable and affordable architecture, the system where the user has all the control to import the models, set up their own sensors. Of course, they can reach out to us for building the Scada systems for them, but they have the whole control to build the dashboard, build their twin, the digital twin that they want for their own choice, completely in their own hands with the SDK option provided, high predictive accuracy with the AI. And we are building the nervous system for the industrial world where machines predict failure, maintenance is precise, and downtime is a relic of fast. So finally, we would like to thank Team Bolt for giving us this opportunity. Thank you for bearing with us and seeing our solution to the end. And thank you.